break, and thank you very much to Airbus again for sponsoring this morning's coffee break. Our next session will be addressing the regulatory challenges of operating UAS over the high seas. The moderator for this session will be my colleague Mike Boyd from the ICAO Secretariat. Mike is a technical officer in the Airspace Management and Optimization section in the Air Navigation Bureau, providing advice, guidance, and technical expertise on ATM operations-related matters to the ICAO Assembly, Council, and Air Navigation Commission. He is the Secretary of the ICAO Separation and Airspace Safety Panel. Ladies and gentlemen, please help me welcome Mike and his panelists.
Good morning, everybody, and welcome to this session of Drone Enable 3. So I just want to briefly set the scene for you as to what it is we actually want to talk about this morning. The convention, the Chicago Convention, as we all know it, has a number of articles in it which are supposed to apply without exemption over the high seas, such as every aircraft engaged in international navigation shall be provided with a certificate of airworthiness. Also, every aircraft of a contracting state engaged in international air navigation shall carry, and there's a list, certificate of registration, certificate of airworthiness, appropriate licenses for each member of the crew, etc., etc. And Article 12 stipulates that each contracting state undertakes to adopt measures to ensure that every aircraft flying shall comply with the rules and regulations relating to the flight and manoeuvre of aircraft there in force. Over the high seas, the rules in force shall be those established under this convention. So essentially there's no getting away from it. Annex 2 as well says over the high seas, therefore these rules apply without exception. And this is the kicker. In Article 12, each contracting state undertakes to ensure the prosecution of all persons violating the regulations. So essentially, my hat, that's a bit scary. We know that there are operators out there who are providing a useful service outside the 12-mile limit, and it's being done so in a safe manner. So just between us friends, ICAO doesn't want to see those guys being prosecuted. We actually want to learn from them so we can update our standards and recommended practices. And this has actually come from the bosses of ICAO, which is the states, which is essentially you guys. Last year at the 13th Air Navigation Conference, the recommendation regarding very low altitude operations specified that ICAO develop a solution to enable states to authorize operations of non-certificated UAS over the high seas. And that's what we're going to start to do today. You might be thinking ICAO takes a long time to do stuff, and that is true. We have a consultative process, and it does take a long time. We like to call it a measured process. But that's a euphemism for 10 years. Some states are asking for guidance now, but as they say, it's better to walk through the forest than to run into a tree. And we have on the panel today some very capable forest guides indeed. So I would like to ask each of them to come up and introduce themselves so you know who they are and why they're up here, starting with Kathy.
Okay, good morning all, and thank you, Mike. Can you hear me up the back? Just to check. Good, I've got thumbs up. Excellent. So thank you to ICAO for inviting me along here to speak today as well. So a quick bit about me, I won't bore you for too long. I'm a UAS pilot and an instructor at Cyberhawk. I joined the company in early 2017 and progressed through their training program, which is definitely not easy. So from there, going to work out in the field, so I do that every week, so operationally working on things like electricity towers and also refineries. So, you know, we're crossing sectors as well. I know there's been a lot of talk here about UTM systems. We've got one more day, you can get through it. And also around the technology that's been used for that. However, I want us to think about the operations that we're doing globally over the high seas. So my aim over the next 5 minutes is to give you an overview of the operations that Cyberhawk is doing over the high seas, so that we can all ensure that any new regulations are appropriate and do not impact the operations in a negative way. So I think we've got a slide up there, yeah. So Cyberhawk have been working closely with our clients. We deliver solutions with a reduced risk, cost, and time. So the scope that you can see here, so we've got a rig, and you can see the types of things that we're inspecting on that rig. That takes us less than 5 days to do that full scope. So previously, that would have been done by rope access. We would have had to have erect scaffolding. So all of that takes time. It's also takes, you know, like more manpower. So Cyberhawk teams work in teams of 2, always 2. So we always have an engineer, observer, and then a pilot. So of course, those previous methods were also high risk for the client and for the asset. So in order to do this, we've been working really hard over the last 10 years that Cyberhawk has been going to develop a UAS pilot training system. So it's a really successful program that we have, and we also have internal certification. So this internal certification far exceeds what the minimum standards are. So we never risk sending a pilot out in an environment like this. It's highly challenging, and we certainly don't send them out unprepared. We ensure that they have the right training, the experience, and the knowledge before putting them in this kind of scenario. So they must understand the risks of operating offshore. It's a different airspace to what we would find if we were operating onshore, and they need to understand that, and that's something that's gained through experience. So Cyberhawk delivers a gold standard. What does that gold standard mean, and how does the asset owner know that they're getting that gold standard? So I'll give you an example. A client like Shell will come into Cyberhawk. They'll spend any time up to a week having a look at our processes and ensure that we are competent to do the job that they're wanting done. Here. There. Next slide. So regulation. So Cyberhawk, we kind of know what we're doing in this sector. You know, we've been doing it for 10 years. We've developed a method that works. It's repeatable. Those risks are smaller than the methods that have been used previously, and they can be assessed and managed through a diligent risk assessment, which is always agreed with by the asset owner. So our teams, both of the guys will meet with the offshore installation manager, quite often the offshore installation or inspection engineer, and they'll go through all the risks that are involved in that task to ensure that everything has been covered. And one of those important things is the heli operations. So we know that helicopters are coming in and out of these installations on a regular basis, mostly timetabled. So what Cyberhawk do to mitigate against that risk is ensure that we don't operate 30 minutes prior and 30 minutes after the takeoff of that helicopter. So another reason that we always have a 2-man team is that we have someone observing as well. So if for any reason a helicopter has to land in an emergency scenario, we've got that extra set of eyes to let our pilot know exactly what's going on. So even though we mitigate for the planned, we're also covering the unplanned operations as well. So no permits are ever issued until all of those risks have been covered, and that includes other operations that are happening on the installation as well, not just like what's around about in the airspace. So at the end of the day, Cyberhawk, we want the regulations to be appropriate to the task and to make sure that they don't have a negative impact, A, on the operations that we're doing offshore, which are really important, and it helps the assets sort of comply with all of their maritime requirements as well. So it's not just aviation that we're talking about here, they also have to think about the maritime side of things too. So we just want to make sure that the regulations are simple and that they're appropriate to our task. And that's all. Thank you.
Hey, good morning. My name is Captain Phil Hall. I'm a pilot for the National Oceanic and Atmospheric Administration, the director of the NOAA UAS program. And thank you for the opportunity to talk to you about NOAA's UAS operations over the high seas. Our mission of science, service, and stewardship means that we are trying to understand and predict changes in climate, weather, oceans, and coasts. Unmanned systems, both marine systems and aviation systems, are becoming a very important additional observing system for us to meet our mission goals. We think UAS bring a huge capability to our ship fleet in particular, and I'm going to briefly discuss some of the operations that we're doing in the ocean areas. And so ocean is really NOAA's middle name, and access to oceanic airspace is very important to us. I'll be focusing on 3 domains where we have conducted flights in flight information regions, international airspace, tropical storms, low altitude land-based flights, and low altitude ship-based flights. So NOAA flies manned aircraft both inside and above tropical storms and hurricanes. This is a very important mission in order to collect data that will improve hurricane forecasts for intensity and track, especially when hurricanes are predicted to make landfall. We believe that small UAS that are delivered from our P3 Orion have a great potential to improve forecasts and collect data where the manned aircraft don't go, very low altitudes and areas of very high wind. And you can see in this picture here on your left, the Raytheon Coyote was deployed from the P3 at about 10,000 feet in the eye of the storm, which is about 30 miles in diameter. The Coyote descends while the P3 continues its flight and is collecting data around the 1,000 to 2,000 foot area. And actually, in this case, it actually penetrated the eye wall of the storm until its battery was depleted. So we're just getting started with these missions. We've been doing them for the last 5 years, and we hope to make this an operational capability. In coordination with the flight information regions, it's fairly extensive. We work with Oceanic Control, usually New York Center Oceanic, or some of the Caribbean nations, to ensure safety. We only fly the drone when it is a tropical storm, which is an additional layer to make sure there's no manned aircraft in the area. We put an altitude reservation in place as well as a NOTAM. This is an example of one of our land-based UAS missions that we conducted in 2016 up in Alaska. This was a Scan Eagle mission based in Barrow, Alaska, which is the northernmost tip of the United States. The mission was conducted under an FAA COA, and you can see clearly from the picture that large black area is the area of operation, and the 12-mile limit is the boundary that follows the coast. So most of the operation was in international airspace. This was coordinated with Anchorage Oceanic controllers, and there were a lot of mitigations used to get this COA approved. It's obviously beyond visual line of sight, 2,000 feet and below, up to 100 miles from the ground control station. The extensive coordination resulted in the flight tracks that you see there. This was done in conjunction with manned aircraft. This is a whale survey mission to see if the UAS could accomplish the same data collection as the manned aircraft. What was beneficial for this operation in particular was a safety risk management document that was completed by the FAA that showed how the density of the airspace is in this area and enabled us to conduct the beyond visual line of sight flights using extensive outreach to the pilot community. This is actually, especially near the coast, is a busy aviation area, as well as a tool that we had to increase pilot awareness of non-participating traffic through essentially a radar feed on the beach. So finally, our ship-based operation. This was a mission that was conducted in 2009. We study ice-related seals in the Bering Sea, many of which are endangered. This was a very complicated mission. It was one of our early missions to complete. Again, we used an FAA COA in the middle of the high seas, so it was international airspace. Initially, we had requested up to 50 miles for this operation, and at the end of the day, we had a COA that enabled us to fly about 5 miles from the ship and 2,000 feet. We didn't have any additional mitigations for non-participating aircraft, so we had to fly in that extended visual line of sight range. So those are just some examples of what we're doing. This is an important area for us, and we are coordinating with all the respective flight information regions. The challenge for us is that there is not a standardized approach for operating in these areas. Every operation is new. Sometimes it takes 6 months to coordinate these operations. Obviously, that's not something we can do all the time, and it's also unknown how we're going to mitigate all the concerns. But we're looking forward to seeing this move forward with ICAO. Thank you.
Good morning. My name is Bruno Boucher from Nordic Unmanned. I'm Vice President Governmental Affairs. Nordic Unmanned is an operator based in Norway. We operate platforms, fixed wing and rotary wings between 2 and 235 kilos, fly VLOS, BVLOS in most European countries, basically, let's say, mostly on the coast. If you know a little bit of geography, the Norway coast is pretty long. It's 2,850 kilometers in a straight line, and we have a long history of oil and gas industry, so of drilling and activities in the North Sea. It means a lot of helicopter activities, so which is good for us because it's a good pool of pilots. So that's why we make our recruitment to get pilots for our operation. The nature of our operations has a lot to do with that. First, for example, oil spills, and unfortunately the oil spills don't respect the 12-mile zone, so they tend to go over or tend to come closer. So when there is a mission to support the pumping or the identification activities, we have to deploy. It is normally done in very strong, let's say, close coordination with the authorities, being Coast Guard or whoever is involved in the operation. So it's kind of a state mission that we accomplish. And those missions are made in environments with a lot of helicopter traffic going around, so there's a lot of mitigation processes in place, especially with the ATCs and everything, and having pilots who have a helicopter pilot background, especially a lot of activities on the North Sea platforms, they know what's going on the other side, so it's easy for us to understand the concerns of everyone involved and to put in place the safe operations. We use GIRIS, the SORA approach, also with our Norwegian CAA, to make sure that all of our operations are safe. We also have missions for emission monitoring. So there's some new rules in place to limit the emissions from the vessels, from the ships. So we have some projects for other government agencies to fly behind the vessels and measure the exhaust, basically, of the vessel and identify the nature of the emissions as if they're within the law. It also sometimes goes a little bit beyond 12-mile zones because large ships tend to stay away from the coast. So we also have operations in that. And also we have some inspection, law enforcement stuff that we do. So some of the challenges we have to do not only with the high seas, but also regulation between the different countries. We have some aircraft that are registered in more than one country, like 4 or 5, because the vessel will follow the oil spill, and again, the oil spill does not follow the 12-mile zone and does not follow the borders of the different countries. So the vessel may be able to sail from one country to the next, and we need to be able to deploy in those different national or international waters to support the activities. So I think that's what we are doing today, and we expect ICAO to help us further develop and deploy for more missions that will help us. Thank you.
Good morning. I'm Jeff Klang, Assistant Chief Counsel for the FAA. I'm based in Washington, D.C., but I live in Chicago, Illinois, home of the Chicago Convention. And as everyone saw the flyers around, we're celebrating the 75th anniversary of the Chicago Convention. And we're going to talk a little bit about some of those applications. They did envisage pilotless aircraft back then, which is astounding, the vision they had. But we need to get a little creative to how we put that application to today's pilotless aircraft. So I just want to I thank Mike for putting up some of the legal aspects that we're looking at. As you know, lawyers are usually last to the game, so we're playing a little catch-up. It's hard enough to keep up with standard technology, but drone technology just keeps advancing. If anyone saw the FAA's roadmap in 2013 for our drone technology plan of action, you could probably see that after a couple of months, that was probably pretty outdated already. 2 years ago, I do a lot of work up here at ICAO. I've been coming here for 30 years, so 6-7 times a year on various technical groups, legal committee groups. So it was about 2 years ago, I had a talk with Leslie Carey and pointed out that, you know, there's a few things in the Chicago Convention that we need to get our hands around. So we finally this year got the Assembly, the Legal Commission during the Assembly put it on the Legal Committee's work plan, and we're actually having a first meeting of some core attorneys from around the world here that are here for another meeting to discuss first steps of how we address some of these legal issues. So just to highlight a couple that Mike had put up. You know, in addition to Article 12, you know, you have Article 17, which deals with the nationality of an aircraft, and that's, you know, it can only be registered in one state, and how that registration is taking place and how an aircraft, which is a drone as well, can carry that document on board the aircraft. Now, of course, we have electronic means to do that. It's just a matter of how different authorities can understand where the aircraft is registered. We know that some aircraft are going across different countries and they're registering in various countries. And the whole rule about only one country can you be registered in at a time. There's also the whole issue of airworthiness, type certification, for example. And having an airworthiness certificate on an aircraft. The U.S., I don't know, many of you know that we have no plans to certificate an aircraft below 25 kilograms. So that's an issue that we need to take a look at. Then you have journey log books that are supposed to be carried on board, and a number of other operating rules and those issues that ICAO really needs to get involved in so that we have rules for drones in international airspace. And as everyone knows, once you're 12 nautical miles outside your country, you're in international airspace, and as you saw in Article 12, the rules of the air in Annex 2 are the rules for everyone that's flying in international airspace. That's our starting point. We are getting together. I have no doubt that we will solve a lot of these issues and come up with creative solutions. Nobody wants to deter all the good applications that drones bring. And there's a lot of improvements in safety in all sorts of fields, as we've seen from our previous speakers, some of those applications. At the same time, we want to make sure that there's no adverse safety impact to the other aviation environment out there. So with that, I will stop there, and I think we're now over to questions, Mike.
Okay, thanks guys. So now that you know the problem and you've heard a little bit about what's happening, we're expecting you to give us the answers. So let us have it. There's some questions coming in already, and we'll be asking these guys. I seriously don't think we'll knock this one off today. But as I said earlier, this is the start of the conversation. It'll be ongoing. So if your questions aren't addressed today, they will be recorded for later assessment anyway. So nothing's going to be lost. But let's get going then. So the opening question that I have is that whilst looking at the requirements of UTM offshore, it would be useful to look beyond what technology is required and consider pilot certification. At present, drone pilots are operating in international waters and international airspace without any form of international license, and most individual country certification is only valid in that country. So whilst we can comply with the requirement of our home country and the flag state of the ship or structure, what happens if operators are from countries where there is no licensing system or no minimal requirements? Should those operators be free to operate in a challenging and complex environment? So there's a thought about pilot certification, pilot licensing. So I'll throw that one, I guess, initially at Kathy. You've got a bit of experience with that kind of thing, and then on down the panel for a bit of opinion. Thanks.
Thanks, Mike. So yeah, in the UK, we set our test. We also have a practical component, as do some of the other countries. Now, I think there are some countries out there that still only have like an online portal where you go and do a bit of a quick theory, and that's your license. The FAA is the Part 107. There's no practical component there either. But we have to think about that kind of environment that we're working in is quite challenging. Although it's lower risk than what the previous methods for inspection for the kind of work that we do, it still does carry risk, and those pilots do have to have, a certain level of experience, and also to make sure that those skills are kept up. So it's definitely something that we need to look at. Certainly Cyberhawk, we sort of operate and ensure that our pilots are working above that level, and we also sort of go through like more than once a year, we're testing our skills. And one of the first things that we learn before we even can go out on our first job, even if it's a survey job, is the manual flight skills. So I know there's some talk yesterday around what happens if your GPS fails, but nobody mentioned about those manual flight skills. You have to be able to control an aircraft if all of your technology fails. So that's quite important that we keep those skills up as well. But it definitely comes down to training.
I think in NOAA, this is a relevant question, and we look at each operation case by case. So if you can imagine the aircraft deployed UAS for a hurricane mission, having Part 107 may not be that beneficial for that operation. NOAA carries all the risk, and that's a state aircraft operation. However, in general, in the high seas, we like to see Part 107 or some certification. And I guess the other side of this coin is if you look at what the military is doing with some of their high-altitude drones, they have a training stream now where you don't have certified pilots necessarily always as part of those operations. So clearly this is something that will have to get addressed.
As I mentioned before, at Nautical Man we have certified pilot helicopters, so that's a good start. If we have new pilots joining for the smaller systems, we insist that they have at least a PPL theory course and exam, so at least they know the rules and what's going on out there. And we complete that with the OEM training program for the practical part. This is what we have today. But and the medical certificate, so we don't need to reinvent the wheel. PPL theory, schools and courses exist. The exams are there. The medical certificates, class 1, class 2, they exist. So we don't need to reinvent that. It's just maybe in the practical part we need to do some more research.
Yeah, and I would just add to what the previous speakers have said. In addition to 107, and of course, as time goes on, those licensing requirements will change with what we learn as these operations continue. But a key part that goes hand in hand with the licensing is that the pilot is very aware of what the operating rules are. And as ICAO develops those rules, I mean, the training is key to learn how to operate in these environments. So I think that's going to be a big part of it.
Okay, thanks, guys. Here's a snappy question. All of the examples except one mention operations at low altitude, where there are a few manned aircraft flying anyway. Any considerations about the impact of drones where they're used at a higher altitude? And I have to confess that this steer we got from the Air Navigation Conference, I was focusing my thoughts on the low altitude stuff as well. And then Phil opened his mouth and said, they're throwing drones out of the back of a flying P3. So, Phil, could we start with you, I guess, and talk about the processes that you use for vertical containment, whether it's just a static airspace reservation or it's dynamic based on the height of the P3 above mean sea level, and then we'll take on everyone else as well. So, Phil?
Yep, sure. So, yeah, for the P3, it's a static, usually, I don't know how long before they put it out because the storm does move, of course, but it's a static area, altitude reservation, which, of course, doesn't include the uncontrolled airspace where you could have VFR traffic, but again, our risk case is that it's a tropical storm, hurricane. We don't expect to have air traffic in that area. So it's a kind of a unique case because it is a tropical storm and not in clear air. So we don't fly those missions in clear air with that medium altitude.
Yeah. Okay, Kathy, how about you with regards to what height are you operating up to, and how do you advise other operators that may or may not be in the vicinity?
Okay, so normally we have a ceiling of 400 feet, so that's a standard. We do sometimes get special permission. So if we have an asset, not usually the rigs and platforms, but certainly wind turbines these days, I mean, they're getting bigger and bigger, producing more capacity. So we do need to fly a little bit higher than that standard. So we have to get a waiver or special permission for that. And we would normally put out a NOTAM if we're going to be flying above, just to let sort of manned and unmanned aircraft know that we're doing those operations.
How about you, Bruno?
Well, the good thing is most of the operation is in very, very low density population, so it's over the water. So if something happens, they splash in the water. Normally there's no infrastructure, not too much damage there. So that's a good thing for the safety case. We have operations above 500, or let's say up to 2,000, 2,500 feet. Again, we use NOTAMs, and if we are in areas with a lot of helicopter traffic, we coordinate the traffic like we are just part of the dance. Coordinate with the ATC. We have some vertical or horizontal separation, and that's how we manage that. But it's again with the ATC. We have pilots are in touch with the ATC all the time.
Okay, Jeff, have you got anything to add with that one?
No, I'd just say that most of our concern is at the lower altitude, of course. But I think the NOAA application, they're keeping in touch with the FAA, and everyone that's at a high altitude, of course, impacts all the transport categories as well.
Yeah. Phil, did you want to follow up?
Well, just, what is easy for us, and we've done a lot of partnerships with NASA with their ICAO UAS, the Predator. Flying above 18,000 feet, or I'm learning in ICAO airspace, the floor of positive control airspace varies a lot. But once we're in IFR airspace, it's actually fairly straightforward so far flying UAS. What is a challenge seems to be between the very low altitude where no traffic is expected in the higher positive control airspace. And we don't have I don't know a good solution. We've been required to chase aircraft often in that area in clear air.
Okay. All right, thanks for that. Well, since we've talked about vertical, how about we talk about horizontal containment as well? Let's start with Jeff and work back this way. Any opinions, Jeff, with regards to how far, what kind of lateral containment there should be on these kind of operations? You're allowed to say no, you have no opinion, by the way.
You know, people come to the FAA with all sorts of interesting applications, and I'd hate to say that one level is, a catch-all for everybody. We try to keep an open mind, and I know the technology is changing quickly, so I'd like to hear from some of my colleagues here first.
Well, basically, we work with the FAA or the other users in the area about a separation that is required from the zone, that no time-defined zone or whatever. Depends on the type of aircraft we have and the characteristics. So if we have a fixed wing that's moving at 30 knots, if we lose control, if something happens where we have the kill switch, we can contain this within probably 500 meters, maybe a kilometer or two. If we have a fixed wing flying a lot faster and something happens to it, we lost communication, and even if there's the process and all the algorithm to bring it back somewhere, you may need a bit more separation. So those are case by case at the moment. There is no rule defined to do that.
Yeah, Phil?
Our experience has been case by case. So we've operated in the Arctic and foreign flight information regions. We've operated in the Caribbean, and it depends on the expected air traffic. One solution that we are exploring and we don't have yet is some kind of ability to detect aircraft from our ships. So if we had some reasonable assurance about there being no non-participating aircraft, that would help us as a state aircraft operation go due regard with some mitigation for the risk of collision with non-participating aircraft.
Okay. Kathy?
I'll add just a little bit to that. We're working closely with assets, so I guess our concern would be that any regulation that comes in at that low altitude is not going to impact. So we don't want, like a blanket regulation, anything below 400 feet. We want to make sure that we can keep working closely with these assets and just sort of, we're not going to be impacting on other aircraft. If they're getting that close to an asset, I think we've got some other worries there.
Okay, thanks. So, Jeff, since you did a pass on that last one, here's a question for you. What do you consider the most intractable legal issue in UTM, and conjecture the solutions?
I don't think I passed on the last one. I said case by case, and I think I had agreement here. Okay, we do have some good legal issues to resolve, and we don't have the solutions yet, but I think this certification issue is probably a big one, and we don't want to unnecessarily do things that will impact the good applications of this technology. And the FAA has made a decision. We're not going to certificate the drones under 25 kilograms, and that may run a little afoul of the ICAO, but we're working together with ICAO now to try to solve that problem. But that's probably number one.
Yeah. Okay, thanks. Has anyone else got something to add to Bruno?
Many people operate in one country, so they deal with one regulation and can be happy or not with it. But we deal at Nautical Man in Europe with a lot of regulation, and since there is no unification yet, a lot of countries start to develop their own things. So it means if I have a pilot in Norway who wants to work in France or in the UK or different countries, those countries will not recognize the other ones and certifications, and they ask them to pass another test. So if it's an online test, I'm fine with that. Half hour, we're good. But sometimes they ask for the full exam. So I cannot have my whole crew going in 20 different countries and take all the exams everywhere. We can't afford that. It's going to take too much time. So for me, one of the challenges really to get this unification. If I have an RPAS pilot license, and I think it's coming, that is recognized in the other countries, and I don't have to go through that stuff again. And the same thing will happen to the registration of the aircraft. I have aircraft registered in many countries. I don't mind doing this, but it's a lot of time and it's a lot of effort, especially if they ask for a fireproof, non-removable identification of the aircraft. If you have 5 of those at the same time, it doesn't look too good. So this is the kind of thing I'm looking for ICAO to implement this before the countries implement their own thing. Then we have to, undo what they're doing, and it may take even longer time.
Yeah. Phil or Kathy, you have an opinion? You're happy with what's been said? Okay. A specific one on rules like the operational logs. Bearing in mind that non-aviation background operators are on the rise, how are regulators supposed to proceed? And I guess the rider to that is without any clear guidance from ICAO at the moment. So this is starting to touch on the solution, I guess. Any ideas, starting at Kathy? How do you think regulators should go with the requirements of carrying logbooks?
Well, at the moment, Cyberhawk, so I come from a non-aviation background. This was not how I started out in my career. But we go out on jobs and we do actually have logbooks for all of our aircraft. So we keep that along with anything that we need to refer to. So if there's any kind of emergency or, if someone has a question, so quite often a client might ask something, we can always show them the logbook and they know that we're, abiding by the rules, I guess, as you could say. But, it keeps track of everything as well and helps with maintenance of our aircraft too.
Thanks.
Yeah, just what I've seen, I think those rules like that don't make a lot of sense. So I don't know the benefit. I get the benefit for a manned aircraft. We face this with training our UAS pilots for COAs. They were required to do the private pilot written test. So they had to learn about the P factor and torque on takeoff of a tail dragger, and then go fly a UAS. So a lot of the old rules didn't make a whole lot of sense. Unfortunately, we have Part 107, which is tailored for UAS. So I think the solution is more of a tailored, there's new rules that would that address the actual requirements.
Jeff?
I was just going to add that one of the legal issues for the ICAO team is to look at this, and I agree. It should be a logical and practical solution. It shouldn't be the same as it is with manned aircraft. However, one of the easy ways to accomplish it, perhaps, is to have this electronic means where, especially if they're flying internationally, you'll have an idea of what the journey was.
Okay, thank you. So related to that, then, another question. What are the panel's thoughts on how ICAO should address the current gap between the Annex 2 requirements for certificates and things like that that would still permit safe and legal operations? Who wants to grab that one first? Jeff, I'm looking at you.
Well, like so many of the working groups up here at ICAO, I mean, this will be joint between the legal work that's being done by the legal committee, but we work hand in hand with, the RPAS panel, and the RPAS panel, of course, will be working to put these rules in place, and it's after a lot of the studies that we do to see how the applications are working around the world.
I think, when I look at some of the things that we think would be incredible to accomplish, which would be flying a small UAS from, say, Alaska over the pole to Svalbard, Norway, and collecting data along the way at low altitudes. In my thinking, there's probably low risk. There's probably not a lot of manned aircraft flights. I don't know that. I don't have the data to support that. So there's a lot of these operations which may be low risk. It would be great to have some way to say that, beyond visual line of sight, in these regions, in these altitudes, is safe, and we have some data to support it, and that would be a good step.
Yeah, thanks.
Support that because the last couple of days I saw a lot of things about UTM and urban environments, and we see all those drones coming together at the crossing. One has to slow down, let the other one up and down. I don't think we have that in high seas or in the big thing. We don't have too many of those crossings. I think it's more about defining areas, maybe categories. The 25 kilo is maybe a good place to start, or maybe less than 150 kilo, maybe a good place to start. To say, okay, if you're at that altitude and you do this, and you are seen, so put some transponder in mode S on that, and okay, if someone else is flying there, they have a chance of seeing you, you have a chance of detecting them, but the density in the air is very low, and the density on the ground is even lower. So I think those, if we could take care of those, I think that will solve a lot of issues for us. But the urban environment, I think, is a different game, because a lot of people there, a lot of risk. If something happens, a lot more damages.
Okay, so I think we have time for one last question, and it's kind of related to what you just said, Bruno. And this one from the floor: what altitude reference systems are being used? You mentioned Mode S on the transponder, that's why.
So our operation in Barrow, Alaska with the Skiing Eagle, my assumption it used GPS altitude. And we actually addressed the issue. We didn't fully, but we were aware that because it also had a Mode C transponder. So the manned aircraft was able to initially, to make sure they could find the drone, they were using TCAS to just get an idea of where the drone might be. And that's not a great solution. And of course, the altitude that you get from TCAS on a Skiing Eagle is probably also not I'm not sure if it was Barrow derived or not, but I don't think any of the operations were using QNS altitudes or anything like that.
Okay, Kathy, what do you use?
We're mainly Rotary Offshore, and so this is all kind of like above. We don't operate at that kind of altitude, so we're not using that kind of instrumentation and connection. So yeah, we're just GPS, just for low stuff.
Bruno?
Yeah, we go for GPS for the small operation. For larger ones, we have both that we can see. We have the QNH we can set, and we also use the GPS. So depending on the airspace and the separation, we have the option. So the pilot can see both.
Okay, thanks. So it's time to wrap up a bit, and I know there's a few more questions that we haven't been able to get to, so sorry about that, but we'll take a note of them. So essentially we're looking at starting to define the problem. I mean, it was a big and amorphous problem to start with, but we're now looking at containment of operations, vertical and horizontal. That's something ICAO is going to have to work on. Licensing and approvals, both for pilots and the operators, is something we're going to have to consider as well and come up with a solution. And that will include medicals for pilots, that kind of stuff. Equipage requirements, is there going to be minimum equipage, transponder mode Charlie, that kind of stuff. And then we touched briefly on the fact that issuing NOTAMs is a way of advising the rest of the aviation industry what's going on. But is that, given that that is texting in capital letters, is that the best solution? Or can we be a bit smarter on that? And then lastly, I've made a note here, one size is not going to fit all. So it needs to be a scalable solution, whatever we come up with. So thank you very much. I just would like any final comments from the panel, starting with Kathy.
I think I'll just reiterate what I said in my presentation. We need to keep it simple and make sure it's appropriate for the task that we're doing so that we don't remove operators that are doing really important operations out over the high seas and also mostly below where, some of this other unmanned aircraft is operating as well.
Thanks.
I think just from my perspective and what I've seen, we've got a lot of great solutions being proposed, remote ID, obviously next-gen ADSB, and those systems aren't supposed to necessarily work together, but of great benefit to me would be the ability for UAS to be able to detect aircraft and for aircraft to be able to detect UAS, which really isn't important unless, well, it's important everywhere, but it's important in the high seas too. It would help us with our risk cases.
I would say it took 5 years for the ICAO and the community to get where we are for manned aviation. And we don't have 75 years to fix the UAV area. So let's get our stuff together, fasten our seatbelts, and move on.
Fly safe.
Okay, thank you very much, and thank you guys for the questions. Well done.
Thank you very much, Mike, and panelists. Thank you so much. We are now going to move into our final session of the morning while the group picture is being taken. And that next session will be on the topic of cooperative separation of stratospheric operations, which is a follow-on to a session we had at Drone Enable 2 regarding operations above flight level 600. The moderator for this session will be Ms. Nancy Graham from Graham Aerospace International. Nancy is the former ICAO director of the Air Navigation Bureau, and prior to that, she spent a career as an executive with the FAA. She is an international consultant now, focusing her practice on aviation's newest entrants, the ultra-high and ultra-low communities. Please help me welcome Nancy and the panelists to the stage.
Good morning. Good morning. Nice job, you guys.
Good to see you.
Talk about traffic management. Whoa. Good morning. Welcome, panelists. Forgive us for that rather inelegant transition. I just wanted to say it's a pleasure to be back. Not with the snow. Goodness gracious. First snow is always lovely here. The next 50, not so much. So it's a pleasure to be back. I had the privilege to start this RPAS work way back in 2007. So it's great to see how much progress has been made even since a very short period of time a few years ago. And I want to just congratulate ICAO and particularly the Air Navigation Bureau for the Drone Enable events. This is a great way to put forward the best practices and put out in front of the community those things that are working well and those things that still need particular focus. I want to just take a hot minute to say a couple of thank yous, Leslie in particular, to Mark, to Leslie's team, and also to Yuri Fata. I don't know where Yuri is here, but Yuri is sort of the innovation key, and I wanted to just thank him for the continued evolution. You know, there's no place for them to learn either, and they don't get to go out and do a lot of field work, so they really do spend an awful lot of time facilitating and understanding what's happening in the community. So particular thanks there. There's a really particular unique focus here. Thanks, Steve. We were wondering what happened to you. This panel is focusing also in international airspace, particularly focusing now on traffic management, cooperative traffic management in the stratosphere. So you're going to hear a lot of examples that apply to the last panel, and then some different ways of thinking about what we talked about for the last couple of days for a unique operational environment. But again, as I get started, I'd like to thank Steve in particular and PK, as well as Robin. Hi, Robin. For their ongoing cooperation as key regulators with this community, which has been operating now for some years. And particularly thank them for their collaboration in thinking about this operational environment and working collaboratively with the industry to support the operations here. And I want to give a particular shout out though to CASA. Is CASA here in the room today? CASA, please stand up from Australia. Where are you? Oh, that just pisses me off. Okay, so I want to give them a particular shout out because they actually happen to be the test bed for a lot of these operations. They are very forward leaning and very forward thinking, and so I wanted to give them a particular shout out for their continued support and future thinking. They're great. They've been really terrific. So this panel is going to start to talk about the concept of operations as seen by the regulators and as seen by the operators in this particular environment. And let me just introduce the panelists so that I don't have to pop up and down and become a jack in the box, or a Jill in the box in my case. So if you could just go waves. Everybody knows Steve Bradford by now. He's a fixture in this event. He is the chief scientist for the FAA, and Parimal Kapadecker, we call PK lovingly. Everybody knows PK, I think, at this juncture. He's the senior technologist for NASA, for Air Transport Systems. Robin Garrity, I think you might be new to this crew. Have you been here before? No, so he's a newbie. So Robin is from Cesar, and we've had good cooperation over the years from EASA, from Eurocontrol, and from Cesar. So he's representing the European community today. And then I would like to also introduce Leo Bouygues. Many of you know Leo from previously. He's from Loon. He's the head of flight operations for Loon. And Andy Tailby. Andy is the head of flight operations for Airbus Zephyr. And they're going to do a tag team presentation. And then we have two also new guys that are new to Drone Enabled that are also operators in the high altitude environment. We have Simon Ashby. Can you give us... Simon just got here, so he's really sort of a deer in headlights right now. Welcome, Simon. Simon is from Sky. And also Dr. Gil Kraus. Gil's also his first time here. He's from the Odysseus program with Aurora. So with that in mind, I wanted to just say thank you to them for making the trip. We've got a very short period of time, but I want to turn this over straight away to Steve and PK, who are going to do a tag team. Over to you.
All right, thank you. Thank you, Nancy. And Steve, it is our pleasure to start off with this panel. Nancy, we really appreciate your enthusiasm, as always. Okay, here we go. So my name is Parimal Kopardekar. My user-friendly name is PK. Steve Bradford, who...
Has no user-friendly name.
His user-friendly name is Steve. And he was my first boss, actually, in 1993. So now we're together on this. It's been a great pleasure to work with him. Next slide, please. Okay.
Do you want to advance them, or do you...
Yeah, advance. Okay, I can just do it here.
Can he advance them here? Clicker.
There you go. Nancy was hiding clicker. Okay, well, we are here to talk about Upper E, which is roughly 60,000 feet and up in the United States. It varies at different countries, but main idea there is to figure out what are we going to do to enable the new entrants in the Upper E airspace. As you know, there are a number of entrants and applications that are emerging, and what's the best way to organize the traffic and management of them. That's the question that we are focused on. Steve and I have been working on the idea of expanding the UTM construct, not necessarily wholesale cut and paste, but the construct of UTM, and we'll talk a little bit about that. As you know, there are diverse vehicles from balloons to supersonic and hypersonic, so the diversity is very interesting in that airspace. And at this point in the United States, at least, the ATC services are very limited or not provided at all, which impacts the ability to scale if we don't do anything. So the possible approach here, or the solution, is to build on what we learned in the UTM characteristics in terms of preparing for scalable, safe, and efficient management of Upper E. So the concept involves similar things as we saw in the UTM in the last couple of days here. It's all digital, it's interoperable, it's cooperative for planning as well as execution, including the separation management, the intent sharing, uses and leverages service-oriented architecture and possible room for third-party services, and changes the paradigm to manage by exception. So the focus, so far, our focus has been on concept development, feasibility simulations, and demonstrations. Here is what we are up to so far in terms of the progress. So you can see the picture that talks about basically operational volumes and how vehicles go up and down, particularly balloon. There will be some that will linger around, some like supersonic will have a 4D trajectory, and so on and so forth. So the idea is to accommodate all of these heterogeneous operations. So we have been building on a ConOps, working very closely with FAA and NASA, and then taking industry's input and making sure that the use cases and operational characteristics are taken into account with their ideas. So we had several workshops starting in last year, and then we did very recently in April, and then we are working on architecture and information management, kind of information exchange construct. We will be doing a tabletop exercise next month to figure out the initial validity of that. And our basic steps include ConOps, which continuously builds on previous editions, and it's a living document, but collaborative tabletop exercise, then architecture, then doing some modeling and simulation, particularly of off-nominal conditions. As we all know, aviation is all about safety and making sure that off-nominal conditions are taken into account, and then doing collaborative simulations and live flight demonstrations. So we will be working very closely with FAA and industry to validate the concept and the construct to make the operations scalable and safe. And with that, I will give it to Steve so he can correct me everything I said.
Which is my job. If anybody saw me on Tuesday, you know I like to simplify things. And so everybody always likes to say that this is really, really complex up here. I like to think that we already have an analogy for what we want to do at this altitude. If we wipe radar from our mind for a second, we go back to the way we originally separated aircraft is pilots would report position to a controller, controller would rack and stack the strips, look for a conflict of time at a point. And then because the controller was the only one who actually knew about the conflicts at a point, he would list instructions for somebody to slow down, somebody to speed up, so we could take care of at only one person crossing a point at the same time. In this environment, it's not much different. We can have these vehicles report their positions, and their closing rates, in most cases, are pretty small. They can find the points of conflict, and because they have the information, I don't need a third party to step in and say, well, let's not both show up at that time, that point at the same time. So we like to think that we can actually go back a step and go forward. We have better information, we have more position, we have better intent, and the decider can be the person who has all the right information. In the past, it was always a controller, and now it can be the operator. And why should air traffic get involved when operators can easily decide, well, we both shouldn't show up at that point in time at exactly the same time. And so I think that oftentimes we try to think that new things are brand new, but actually we have analogies in air traffic for a long, long time, and we can leverage them and we can use them if we just go back to first principles. And it's no different than what we're doing with the previous panel. They said, well, do you have to carry your logs on the vehicle? What are the intent of the logs? Well, here, what was the intent of sharing time and position was to assure that nobody was at the same time and place. So I think that this is a fairly easy concept if we move on from, this is really, really complex, to, this could be really, really easy if we went back to our first principles.
Perfect. Thank you. Thank you, Steve. Let's thank him. Robin, could you share your view from Europe? Love that perch. Please, please.
That's the presentation, yeah. Okay.
It's coming.
Good. Well, good afternoon, everybody. I'd like to give the point of view from a European perspective, although as a British person, I'm not quite sure how long they're going to allow me to do that. So, with no further ado, okay, thank you. Okay, what's the problem? We have heard about this from the previous speakers, but it's so important, I think we need to bear this in mind. We have a lot of new stakeholders and operators involved, vastly new vehicle types with a hugely varied vehicle performance, all of which will have an unknown network impact. This is an entirely new problem that we need to address, and it will need novel and interesting solutions to make it safe and effective for the operators. We don't know the performance requirements of the system that's going to support all this yet. There are new services being produced and needed to support the operations. Do we need new airspace division classification or even a whole new airspace concept? And do we need new flight rules? All these are questions that will need to be answered in the near future to enable this to work effectively and safely. And of course, new separation provision concepts and high degrees of digitalization and automation. I shall come back to that theme. Within Europe, the CESAR joint undertaking has actually been responsible for much of the IFR RPAS integration work and also for the work on USpace, which is the European flavor on UTM. It's worth looking at what the USpace definition is. It's a set of new services relying on a high level of digitalization and automation of functions and specific procedures designed to support safe, efficient, secure access to airspace for large numbers of drones. And the next one is that it's an enabling framework to facilitate any kind of routine mission. And there's a few examples listed there. This concept is actually very similar to the collaborative traffic management system being discussed here today. It's collaborative, it's competitive, and it's service-based. But we can also learn lessons from our IFR RPAS integration work, in that we knew trying to get unmanned aircraft flying with manned aircraft is not something you can do in a big bang. You can't just do it. It's got to, something evolve, you try, you test, you develop regulations, you get to gain experience, and you learn from that. So in fact, in common with the ICAO principles, in Europe now we're doing it in largely two steps. One is accommodation, as we actually heard today about the flying over the seas, by allowing it, but with conditions, with rules and with protection, while we work on the full integration. And so therefore, to integrate even the higher airspace, to allow the systems to work together, we need a step-wide approach, understanding and addressing the needs of the many new vehicle types. And this will require us to come up with solutions to allow them to fly now, with as much possibility to give freedom to the businesses to achieve their tasks, and yet maintain safety. And in future, the research and the evolution will lead to a fully coherent system. Now, I started this presentation with a little joke about my nationality. There was a reason for that. If you look at this map here, this is a map of Europe. Sure, you can just see the outline of the states behind there. But all the darker lines are actually the ACC boundaries in Europe. Bear in mind this area is not so very different from the continental US or from Australia. And yet we have all these ACCs, even 3D. So there are some boxes there that show different ACCs responsible for slightly lower airspace. This is difficult, it's highly fragmented, and there's a strong sense of sovereignty requirements, hence my joke about Britain. And this is a major problem for us. So to have a collaborative environment, the system that CTMS is looking at, it's actually going to make things even more difficult with the political standpoint here in Europe than it is in areas which have a more coordinated approach to large volumes of airspace. So, even for the slightly lower airspace, what we've done in Europe, the request of the European Parliament, CESAR produced the European Airspace Architecture Study. This is looking to move away from our very fragmented approach based on where the CNS assets are owned and where they sit, to a much more digitalized and connected environment, permitting the delivery of new services, virtualized services, trying to make things smoother and more efficient in the upper airspace. This model could be extended into the stratospheric airspace. So what are we actually doing about it in Europe? Well, we have the Airspace Architecture Study Transition Plan. It's been published. Both the original document and the transition plan are available on the CESAR website. You can have a look at them. This will try to give you an indication of how we're going to get from now state to the nirvana. And then we have, of course, work continuing on use space. We've recently published the Chorus ConOps, which is the concept of operations for use space. And many of the concepts which are in that document could also be applied in exactly the same way that we heard PK talking about the lessons we're learning from UTM. And what's current, I mean really current, this week and next week we are evaluating proposals for exploratory research programs within the CESAR program, one of which comes as a result of a tasking from the European Commission to, tasking from EASA, the European Aviation Safety Agency, to Eurocontrol to work with the SJU in working out a concept of operations for higher airspace operations, stratospheric operations, and this is being evaluated this week, so hopefully we'll be able to have some news on more development work going on, which will be a collaborative work between industry and regulators and, of course, the international community. So in conclusion, we know that stratospheric operations are here and demand is growing. The variety of new users is staggering, which does introduce some significant challenges, as we've already heard. Detailed research and development is needed to devise solutions, including innovative proposals like the CTMS ConOps. Introducing such new operations and stakeholders mirrors UTM, the UTM revolution, and lessons can be learned and applied. But UTM is still in development, and the concept needs substantial evaluation for applicability in the stratospheric context, and all that needs research work. Well, current new operations and operators and stakeholders need early involvement, in particular those new to aviation and existing service providers, in order to achieve a consensual solution. It must be a consensual solution to be collaborative. We need an iterative approach. We can't do a big bang. We can have an idea, we can work at it, and then we can work out how to get things flying as soon as we possibly can while we work on the more difficult goal of getting things fully integrated. And by integrated, I don't mean at a vehicle level, because clearly the concept does try and put the vehicles above normal aviation, but the systems have to integrate. And then Europe requires a global regulatory provisions, which is obviously why we're here at ICAO now, to enable the development of a pan-European approach from our perspective to managing the stratospheric operations. Thank you very much.
Thank you, Robin. Nicely done. So next you're going to hear from the operators and a couple of ways where they're different and they're the same in terms of our past work. So a couple things. At the high altitudes, it's low density, distinct from what's happening in lower altitudes. In the higher altitudes, they've got to get through controlled airspace, so they carry everything and then some that an aircraft would carry to get to a higher altitude. And so you'll hear some of the same concepts, and they may have slightly different wordology, but you'll hear some of the same concepts as it makes sense to apply. So with that, I'd like to introduce Leo Bouygues from Loon and also Andy Tailby from Zephyr, and you guys are going to do a tag team on the presentation of this concept called Cooperative Traffic Management Separation. Cooperative Traffic Management for the Stratosphere. Andy? Sorry, Leo. Leo first. Oh, sorry, I forgot one thing. Can you put up that slide again? So just before he does that, we want to just give you the address again for the questions. So I am the pop-up in the box, I guess it is. So this is the website or the address where you can write your questions. We love your questions, and so I wanted to put that out again as you begin this process so you have some insight into where to send your questions. And now over to you, Leo.
Thank you, Nancy. Good morning, everyone. Pour les francophones, bonjour. My name is Léonard Bouygues, and I'm the head of flight operations for Loon. And today, what I want to do is to give you a perspective on the industry views for cooperative separation in the stratosphere. And so what I will try to show you is how we can bring the concepts from the lower altitude, use them to bring cooperative separation at the higher altitude in the stratosphere. But I also want to point out some key differences of how operations work in the stratosphere and that we need to take into account in order for the CONOPS to be successful. I want to thank the panelists and the industry who contributed to put these views together. One last point before I start is I'll focus exclusively on what happens once the vehicles are at altitude. We know they need to transit through the airspace, but we'll focus exclusively on what happens at altitude. So at this point, you may be wondering, what is flying up there? You'll hear from a few panelists and few initiatives that happen up there. But what I want to get across is that operations in the stratosphere are real. They're not from tomorrow, they are from today. This is the map of operations of Loon balloons throughout 2018. A single operator operating globally large fleets of unmanned balloons that control their altitude using the wind. You can see that it is global. The flight durations are long, 175 days, up to 223 days. And this will be a general characteristic of operations in the stratosphere, as you'll see from other industry players. It is also largely automated, highly automated. The operations in the stratosphere, it's difficult to reach the stratosphere, and you'll have very highly skilled operators operating in the stratosphere. So PK and Steve mentioned why we need this concept of operation. What are the needs in the stratosphere? Safety is always priority number one. We also need a system that is affordable and scalable to manage those largely highly automated operations at scale. I want to insist on the need for interoperability. You saw that these operations are global. That means that industry cannot work with 190 different approaches to how operations are done. We need to have, and this is why we are at ICAO today, we need to have a uniform concept at high level. I also want to point out to some key challenges in the stratosphere. We mentioned the international nature of the operations, the long duration, 6 months, several months, over a year. But there are also operations that are slightly different. What you can see in this image on the right is the non-deterministic nature of the trajectories of some of these vehicles. That means the projection is not a point-to-point, it's a probability distribution over time. Vehicles in the stratosphere will be highly different. We'll have balloons, you'll hear from all other technologies, and potentially future transport, supersonics, transitioning commercial space. So where does this cooperation apply? There are two things to realize. The first one is that the definition of airspace structure is not uniform across the world. Some countries manage their airspaces up to 60,000 feet, like the US or like Australia. Some other countries, like South Africa, manage their airspace up to 45,000 feet. Additionally, the airspace above 50,000 feet, for most part, is very loose, has very low aircraft density. Most of the operations up there are military operations, but this airspace is very useful and is indispensable for operations like Loon or like Zephyr, and so we want to be able to use that airspace. So rather than introducing an altitude that is fixed across countries or specific to a country, we wanted to introduce this concept that is more general of a deconfliction flight level. The idea is a flight level that is set by the CAA that is defined to be above where most of the traffic is. It is not a flight level or an altitude that is static in time. It can be adjusted tactically. And it is not also uniform. It can vary within an airspace to accommodate for the airspace that is below, the needs of the airspace that is below. But in a sense, once the vehicles are at altitude above traffic, they can separate from one another using cooperation practices. And this is not something that is completely new. What you see on the screen here is the trajectory of a single flight lasting 173 days that oscillates from 65,000 feet to 50,000 feet. And the 50,000 feet is not a coincidence. It's not that the balloon, in this case, cannot go below, but it's because the control operations of this balloon coordinated with each traffic control center a minimum altitude below, above which the balloon should maintain and above which the fleet could manage, self-manage its altitude. And so this has been essentially put in practice everywhere where Loon has flown, and air navigation service providers across the world have asked other operators and Loon to deconflict once they are at altitude. When there's other balloons or other high-flying vehicles, the ask is to say, can you manage your separations amongst yourselves as long as you remain above that altitude? So what we are discussing here is nothing new. It's expanded from the low UTM principles that were developed across industry, across regulators, with the input from NASA, FAA, etc. It all works starting with operators. They command and control flight, the vehicles at altitude. And they have one responsibility, which is to resolve the conflicts that are identified. Now, similar to the UTM construct, they rely on what can be a third-party service supplier, what we call here a platform service supplier, which is analogous to the UTM USS. We called it platform because we wanted a more generic platform. It's not necessarily only a UAS. But the idea is similar. They share intents, and in return, the platform's service suppliers return conflicts. Now, CAAs and ANSPs can interact with those suppliers and provide authoritative constraints, read from the system to get awareness as well as notification of emergencies. Like in the UTM construct, with a federated environment, many platform service suppliers can operate in the same airspace at the same time and provide those conflict identifications. So just like the UTM, we need a service, a federated service for discovery and synchronization, DSS. This is the same concept as in the UTM. And once platform service suppliers know who to coordinate with and have a synchronization method, you can have standards that allow the exchange of information between of the operations between the platform service suppliers. Lastly, national security organizations want to have awareness about the airspace and can send authoritative constraints as well as get the national airspace data and situational awareness of what's going on in the national airspace. Mentioned the DSS. This is taken straight from the ASTM standard. It's a federated system, and with two goals essentially. The first one is to make sure platform service suppliers know who to coordinate with, and the second one is to make sure that the platform service suppliers have a way to make sure they have the latest information and know what is up to date. There are some key differences that I want to point to. Because vehicles are up there for a long time, because vehicles are very different in the way they operate, that means that we need to ask the following questions. What does too close mean? What is a framework for deciding if two balloons can be at a specific distance, or if a balloon needs to be a different distance from a supersonic? And that will depend on the characteristics of both of the vehicles in the conflict. And because we mentioned long duration, several months, and the operators are going to update the trajectories over time, they could update that every minute with a refined plan, refined trajectory over time. We need to ask the question, when do we want to be notified about a conflict? Is that 5 days? Is that a few hours? And that will depend on, again, on the situation. It will depend on the time horizon of the conflict, on the maneuverability of the vehicles. How long do we need to resolve that conflict? It will depend on the probability of that conflict, as well as the severity of a loss of separation. You can imagine that a conflict between two unmanned vehicles over the high seas is not the same as a conflict with a future transport supersonic and a balloon. So here, similar to what you know in UTM, some possible representation of trajectories. You can see a non-deterministic balloon trajectory at the bottom, growing uncertainty over time and replanned every few minutes with more details of what's going to happen in the future. You can see a transiting solar hail, a solar hail that is station keeping, doing figure eights, or like an airship could be static in a single point. And at the top, you can see what is potentially a very fast transportation, maybe supersonic or maybe a military aircraft that is flying much faster than those vehicles. All these need to be taken into account. Before passing it to Andrew, who will provide some examples of how Loon and Zephyr set coordination in Australia, I wanted to just finish on the next steps. So this is work ongoing with the industry, with a lot of research yet needed. This framework that on separation that I mentioned needs research. This is nothing has been done, and we need to continue, as PK mentioned, with tabletops exercises, with operational trials, and with simulations, and that will happen over the course of next year. Thank you.
Thank you very much, Leo. And over to Andy. Clicker to the right. Thank you, Andy.
Clicker to the right. Story of my life. Thanks, Leo, for setting the scene. I'd now like to talk about a specific example of how we're doing cooperative traffic management in the stratosphere right now in Australia. When the slide comes up, you'll see some images of the two craft that we're talking about. The one at the top is in the stratosphere. The one at the bottom hasn't quite got there yet, but I didn't have a picture of your fully inflated balloons in the air. No. And therein lies the problem. So we're talking about keeping these things apart. We haven't yet got the money shot of where they're closer together that we can actually take an image of one from the other. So be it. Nancy also mentioned our gratitude to CASA, and I would actually like to emphasise that and indeed extend it both to the CASA RPAS branch, who have been very forward-thinking as far as we're concerned, and also to the CASA Office of Airspace Regulation, equally forward-thinking. And above that, also to Air Services, who are the air navigation service provider, with whom we've enjoyed a great deal of cooperation in Australia, and without whose help we could not have done this. So I'm going to review some of Zephyr's characteristics as they affect air traffic management. Won't dwell on that too much. Going to tell you about how we operate in Australia. I'll briefly cover the getting up and getting down bit, but most of it's about extended operations in the stratosphere. Briefly then describe what Loon and Zephyr currently do to stay out of each other's way, and like Leo, finish up on a few suggestions for how we might move forward in future and in a practical sense. So let's start with Zephyr as an example of a solar-powered, high-altitude, long-endurance aircraft. And the reason these things work, as no doubt Gil will emphasise later on, is that it's a very careful balance of lots of technologies and lots of capabilities to make the energy budget stack up. The consequence of that is invariably that they are very lightweight, and the consequence of that is that they go slowly and have a modest performance and a certain limit on their manoeuvrability. All of that, in the context of air traffic management, means that there is a limited ability to conduct collision avoidance, which places even more emphasis on the provision of safe separation in the first place. Second thing to bear in mind is that although it looks like an aeroplane, it kind of doesn't operate like an aeroplane. You need to think in terms of extremely long flights. We've demonstrated 26 days. We are thinking in terms of 1 year. Therefore, we're not going up and coming down per aircraft very often, and we're likely to do that in waves from particular locations, possibly even on a seasonal basis when the conditions suit, and not in order to make a precise slot time, if you like. And when the aircraft are up there, they're going to be hanging around for a while in holding areas and above mission areas. We've touched on the fact that obviously this is a global enterprise, and some really interesting points came out of the previous session around that, which challenge us just as much as they challenge smaller aircraft. And we're talking in terms of strategic operating centres and highly networked communications systems. And finally, in order to deliver mission effect in some missions, we talk about constellations of Zephyrs, and we will need in future also to deal with the infamous M to N ratio, that is to say using less people to operate more aircraft. So let's just talk quickly then about what we do now and how it works. I will go from the ground up. This is how it works in Australia. First thing we need to tackle is uncontrolled airspace. Class G airspace in the area that we operate in the northwest of Australia, below flight level 180. And here we use pretty traditional methods to accommodate Zephyr launch and recovery in the form of temporary restricted areas. And CASA have kindly afforded us the privilege of controlling those temporary restricted areas in Class G airspace. And we do our best by careful timing of when we operate those things and by allowing other aircraft to pass well clear whenever that is practicable to minimize the impact on other airspace users. And this, I think, is a key theme. So this unusual CONOP, this unusual modus operandi of these rather distinct vehicles invariably means that they are going to be potentially in conflict with conventional operations. And it behoves us to maximize the principles of the flexible use of airspace in order to cohabitate nicely. So we get up to flight level 180, we're now going to controlled airspace. This is where air services come in. We have an extensive letter of agreement with air services which determines how we operate in Class E and Class A airspace. They now provide the separation on blocks of airspace that we occupy. And again, those airspace segments are managed carefully in order to control the impact that we have on other aircraft. And then we get to this thing called the deconfliction flight level, which has some important characteristics. The first thing to bear in mind is that as Leo said, it is a flexible thing. It is variable, it can be adapted to suit the circumstances. As it happens, in Australia, we use 550, that is our deconfliction flight level, which we've agreed. But that is not a flaw for Zephyr operations. It's not something we can't ever go below, but it is a boundary below which we need to behave differently to when the aircraft is flying above it. And we've selected that flight level 550 in conjunction with the ANSP to afford a pretty generous, actually, 5,000 foot margin, if you like, between the very highest credible conventional traffic, let's say commercial traffic, and the lowest that Zephyr might go, bearing in mind that we're only talking about one of the 4 dimensions available to us here. So let's just talk now about what we do above deconfliction flight level and how that works for us in what we might call cooperative airspace in current operations. First thing is to note that that deconfliction flight level does not coincide with the top of Class A airspace, which in this region is flight level 600. It is different. And so one of the privileges that the ANSP affords us above DCFL is the ability within a very large defined operating area to operate pretty much as we please. We only have to keep them informed of what we do through regular but somewhat infrequent communications. And we also are afforded the privilege of exiting upwards and entering downwards Class A airspace whenever we like, as long as we don't anticipate going below DCFL. So that's great. That gives us massive flexibility of operation, and the area of operation that we are afforded is very generous as things stand at the moment. But it does bring with it an obligation, and it is that same obligation that Leo mentioned, which is to not bump into anybody else who happens to be up there. And in this case, the other entity which is likely to be up there is Loon Balloons, and we'll talk about how we do that deconfliction at the next slide. So I just want to emphasize that all of this is designed with great care to be consistent with the concepts of flexible use of airspace in order to afford equitable access and, as far as we're concerned, to minimize the impact on other people. So that's great. That's all fine and dandy as long as everything is working well. But we obviously have to deal with off-nominal conditions as well, as a lot of people have emphasized already. So how does that happen? Well, this is where, again, those differences between something like Zephyr and an ANSP's expectations of the behavior of traditional conventional aircraft needs to be modified, because it isn't going to happen just as it would with a conventional airliner, let's say. We need, therefore, to help everybody understand how things are going to behave, how these events are going to unfold. And that is one of the important aspects of the letter of agreement that we have, which describes our concept of operations for the benefit of the air traffic controllers that we have to deal with, and sets out the simple principles that we need to apply. Now, when things go to rats in normal aviation, the mantra is aviate, navigate, communicate, which is fine. The thing to bear in mind for us, especially when we're talking with other sort of low dynamic platforms, is that things don't actually develop all that quickly. So we prefer to go aviate, communicate, navigate, because actually the navigation that ensues when we have a problem, and we may need therefore to have an unplanned descent into normal ATM airspace, necessitates that we negotiate with the ANSP as to exactly where this event is going to occur, and take ourselves there to give them the opportunity to take the steps that they need, basically to move people out of the way, and in the case of the way we operate in Australia, to themselves establish a temporary restricted area or areas in effect, which will allow us the safe separation that we need. So if you think about a generic set of issues that we might have, which we call a gradual loss of flight performance, could be for a lot of reasons. Zephyr is a very resilient aircraft, but we have to assume that things could go wrong. We would expect to be able to predict where we're going to go, how far we're going to be able to go, and how far down we're going to need to go in plenty of time. The sun is our friend with a solar electric powered aircraft, so it may well be that having suffered a problem with some solar array, for example, we might find that when we get to the morning, we can climb back up again. And so I introduced there, in very general terms, the concept of stepping stones of managed airspace that we can use to get back to where we need to go. The challenges of lost link are pretty much the same for us as they are for anybody else, but of course in isolation up in the stratosphere, lost link doesn't particularly bring any additional deconfliction problems because we know where it's going to go, and we've already briefed the ANSP what the lost link flight path is going to look like. We also will consider transponder failures. That's pretty standard stuff, and again we benefit from the relatively low traffic density. But a key point to bear in mind as we go forward is that when we are in a more dense traffic environment in future, when we have our commitment to respecting collaborative traffic management requirements, we may also need to consider any challenges of navigation that will allow us, that will prevent or could prevent us from being able to comply with that. Okay, let's talk about CTM proper then. I don't need to dwell on this. Leo has already, and others have already covered it very well. You get the idea. It's kind of UTM moved up to the other end of the other side of the ATM airspace, if you like. I thought it might be useful to do a quick sort of inventory of the key components that we have and those that we need. The ones in italics I'll talk about in more detail in the next slide. So we've got this DCL boundary. We need a protocol so that we all know what's going on. We've talked about accommodating Zephyr operations below DCFL. Yeah, we need this synchronization service in order to know who else is out there, but actually at the moment the telephone directory isn't all that thick, so we kind of cope without one. But we obviously need the means to identify a potential conflict, and we need the means to resolve said conflict should it occur. How do we do that? Here's how we do that. It's relatively straightforward at the moment. It's a human-centric, that is to say it involves us, and not a very high level of automation. It is position-based at the moment. We don't do look ahead too much, and we can afford to do that because the only two actors that are involved have relatively low dynamic vehicles. That is going to change. And obviously this is constrained to the areas that we know we may cohabit in the near term. So remember, stuff develops quite slowly as far as we're concerned, and because we don't need to use the airspace particularly efficiently at the moment, we can be a bit profligate with our separation criteria, which errs on the safe side. So those three things that are missing then, the CTM protocol, Well, we have a procedure. We have an SOP which we share, and one of the key characteristics of that are the fact that we need to know how the other guy is going to behave, how that vehicle can contribute to a conflict resolution, and it transpires, broadly speaking, that loon balloons are more agile vertically, and luckily Zephyr can maneuver laterally relative to the air mass. So that helps us to sort that out. Obviously on the left of the slide is what Loon does, on the right of the slide is what Zephyr does, and the bit in the middle is what we share. As far as conflict identification is concerned, we benefit from Loon's online air traffic monitor, which basically tells us where all of their balloons are all of the time, and they kindly afford us access to that, thank you. And on each side of that tool, we're both keeping an eye on where the other is. So we've got a bilateral thing going on here, no single point failure. If, according to very precautionary criteria, we think, either of us thinks that there is a potential for a conflict to develop, well, we pick up the phone. What do we do when we pick up the phone? We negotiate. We have a set of rules, and we basically agree what each is going to do, or what one or the other is going to do in order to resolve the conflict. It's pretty straightforward, and you can see there that in standard air traffic terms, we aim for some particularly or fairly precautionary separation criteria. We say 10 miles and 3,000 feet. I think the reality is it's going to be an order of magnitude more than that, probably laterally. We're talking about big distances here. But we do need to bear in mind the rules of the air exist. He's a balloon, we're a powered airplane. We would need to get out of the way if we couldn't play nicely together, which is highly unlikely, of course. And once we've decided what we're going to do, then we each play our part in that conflict resolution, and evidently we check and confirm that everything is unfolding as we expect. Key point, we're learning too. So if ever this happens, and we haven't had one yet, then we will report and we will learn from the experience, and we hopefully will be able to share that with you in the future. Nancy, let me just wrap up by reiterating what my colleagues have already said several times. We need to move from this relatively simple, human-centric, position-based system that we have now to something that's more highly automated, 4 dimensions, intent-based, universal, allows a degree of uncertainty and prediction, and is able to cope with diverse dynamics as far as the vehicles are concerned. We all want to go around that virtuous circle that I illustrate there of sharing knowledge and developing what CTM might look like in the future. There are some practical steps that I'm proposing there about data protocols, connecting our fleet management systems together, actually deliberately executing real-world encounters and learning from those. Vital that we engage ANSPs, and also vital that we draw upon the relevant lessons of UTM without necessarily taking on board all of the stuff that pertains to that very busy low-level environment, which doesn't necessarily affect what we do. And we all need to work, don't we, PK, on tabletop exercises, multilateral simulations, and take a long view of this, because we have a great opportunity now, folks, to learn from real experience before it gets really busy up there and we end up having to use this stuff in anger. So let me just briefly conclude then that the accommodation of solar high-altitude, long-endurance aircraft in the stratosphere in uncontrolled and controlled airspace is happening now, and therefore is practicable. We have got to evolve the way we do it, though, and we shouldn't underestimate what we need to do in order to accomplish that. But we can and must learn from our near-term experience, iterating towards that utopian circumstance that we're looking forward to in the future by building a universal regulator and industry consensus. Thank you very much for your attention.
Thank you, Andy. Simon, come on up. Let me introduce Simon Ashby before. I haven't gotten the side eye yet from Leslie, but I will in a few minutes. Okay, so we're running a few minutes over, but I think it'll take, these are also new players, and I think it'll take about 10 minutes for the 2 of them. Okay? Thanks. Over to you, Simon.
Thank you, Nancy. Hi, everybody. Hi. I represent a company called Sky, spelt with a C. And I'm here to talk about our view on the CTMS, but I also want to introduce Sky as a platform, as a user into the CTMS. So we've heard from the regulators and also from operators like Loon and Zephyr about how they see it working. We're coming along, and we're going to be one of those new platforms up there, and we're going to be up there soon. And we need to be able to play in the same space, and we all need to be operating in the same space. So, how do I change slides?
Here, let me do it for you.
Okay.
Just make it faster. Go.
Right. So the objectives I'm looking at is who are Sky, who are we? How Skycraft will operate in the stratosphere. It won't be much different to how Loon or Zephyr are operating in terms of concept of operations. And then some views on the CTMS. So first of all, I'd like to show a video. It's about the same length as a pop video, so it's not too bad. We should be able to stay awake. Think Taylor Swift if you get bored. If we could play that. Thank you. Not working?
We're getting the death circle.
Right. Can it play through the PowerPoint? Here we go. Right, okay.
Gentlemen, we're just going to do a quick final briefing before we leave the hangar. So we want to prepare the ship to be ready to come out at 6:30. Our latest track we've got from the last week, which is actually better than the previous one. So we're now clear and we're landing a little closer than the previous track as well.
I know that's a bit dramatic, but when we were doing it, it was dramatic, I can tell you. It was also very cold. This is the third good thing to come out of New Mexico. The other two are good beer and good chili peppers. So I hope seeing that you see some of the challenges that we have. We have to fly a platform. We're looking at an airship from the ground into the stratosphere, through controlled airspace, get it into the stratosphere, keep it up there for up to a year, then bring it down. When it's going up, it's going up. There's not a lot stopping it. And when it comes down, it comes down. Again, there's not a lot stopping it. So we need to work with the ANSPs, the regulators and so on how we best do that. That was a balloon. We're moving into airship territory in the next flight. So Sky 1 in 2020 will be powered. It won't have much power. The actual power involved, you've probably got more power in your lawnmower than we're putting into this airship. So we won't have a lot of maneuverability. Going forward, there will be more power, but still, the way we're flying means that we won't be able to go up and down. We will be able to go up and hold, but if we have to hold too long, we lose our ability to go up to the stratosphere. So we have to work with you guys, the regulators, to make sure we can undertake the mission we want to undertake. So what we're looking at in our concept of operations, we have a flight profile, which people have talked about before. We launch in the center float pressure. The altitude we go up to is dictated by how much gas, lifting gas, we put in. We fly by aerostatic forces, not by aerodynamic forces. We are a high-altitude, long-endurance solar electric aircraft. It's a bit of a mouthful, so we use the term HAPS. And HAPS, we see you have lighter than air, aerostatic, and heavier than air, aerodynamic. When we're in mission phase, we'll be at float altitude. Mission, we could be up there for up to a year or more, similar to Loon, similar to Zephyr. And we'll be in a mission phase then, and you go to the one-to-many. Again, that's been mentioned by Zephyr. We're looking at one operator, one mission controller for multiple platforms. If we go tech, that's another word for denormalization. I'm an engineer, I tend to use different terms. We would hand over to the pilot to bring the platform back into control or to terminate the mission. And then we would terminate in conjunction with the ANSP. However, people have emphasized that we could be anywhere in the world. We could be launching, say, in New Mexico. We could be operating in South America, over Africa, over Australia, over Europe. So we are working on beyond radio line of sight. We won't be able to return home. When someone said the default factor for a low-altitude drone was go as high as possible and go home, well, we can't do that. We've got more challenges. So we have the concept of flight and mission control. Mission control, we see it located around the world. One of the learnings from drone operations in the military was that you want to try and keep people in their working hours. If you start taking them outside of their working hours, you start having impact on mission control. So we're looking at the concept of 8-hour shifts going around the world. And then you have regional control. So you've got to launch and fly, launch and recover under RF link. You've got to be, if you can, within line of sight operation. Thank you. So how does this go into the CTMS? Regulation. I need to know what requirements I'm working to for my platform. Had some interesting comments made by the Deputy Chief Counsel at the FAA about how the FAA see this. Are we FAR 107? Can that be extended to cover heavier UAS? At the moment, 107 covers lightweight UAS. Could we extend? That would make sense. But we're also going to be an airship, so are we going to have to follow general aviation rules, or can we go up as a balloon? Then we've got data exchange. The message I've got here is that people have done this before. My background is geospatial. I'm coming into this sector with new ideas. Most of the people in Sky have come in with new ideas. That's why we've got to where we've got. And you've got systems out there already. I see this as a geographic problem, and that we can solve this. The Open Geospatial Consortium, for example, have already defining open standards which we can work to. So build upon what has been done before. And it's got to be open. We've got to be able to develop. We've got to be able to share. Some constraints, operational flexibility. At the moment, we're all learning. In time, we're going to become a lot more mature, but there are going to be a lot of new entrants coming in over the next 5, 10 years. We've got to be able to accommodate them and welcome them in. We've got to respect established process. We're not coming in here as a new kid on the block saying, hey guys, we're going to do it different. We respect what is already going on. We've got to work with that. We've got to avoid overly expensive systems. We are small at the moment. We can't afford expensive air traffic control systems being put on top of us. We can't manage that cost. And also, we've got to be scalable. At the moment, we're talking 1 or 2. I know Loon have flown 1 million kilometers. They've done really well. We all aspire to that. But in time, we could have thousands of these units up there providing all sorts of capability in Earth observation, telecoms, and position navigation and timing. So we've got to have a solution which will scale. In 10 years' time, we might have tens of thousands of these things up there. Thank you.
Thank you very much. Thank you. Gil, come on up. So I don't see a lot of questions, and we won't have the time, so I'll just do a closing once Gil finishes his, and he's going to chat with you a little bit about Aurora's product.
Thank you, Nancy. It's a real pleasure to be here, and I really appreciate the invitation and the opportunity to share the stage with some of the pioneers in the industry and the early adopters of stratospheric flight. Many of you probably are not aware of Aurora. We have been around for about 30 years. We were started in the late 80s by John Langford and have been focused on a lot of innovative aircraft design. We've done something like 20 clean sheet designs, and 2 years ago were adopted into the Boeing family. We are part of the Next organization that Mildred mentioned in her Tuesday remarks and fit into Boeing in that way. What I wanted to do was introduce you to Odysseus, our high-altitude aircraft, and also talk a little bit about how my thoughts are on what's different about the operation of a HAPS platform versus a standard low-altitude aircraft. The missions that we have envisioned for Odysseus are communications, scientific missions, military missions. So communications, cell tower in the sky type of operation, what some people call a bent pipe, where you're doing communications relay over the horizon. Science missions, maybe either Earth observation or atmospheric sampling types of things. And a number of different military types of missions, comms relay, surveillance, reconnaissance, that sorts of things. There are several distinguishing characteristics of HAPS aircraft versus typical aircraft. One is being the ability to maintain station over long periods of time, more akin to a satellite versus an aircraft. But unlike a satellite, you're able to bring it down and retask it easily, so that it bridges the gap between typical aircraft and satellites. This is an image of our aircraft rolled out onto the taxiway. A couple things you notice right away. One, it's a huge airplane. Its wingspan's larger than any of the transports that you flew in here on, but it weighs less than any of the cars that you drive. So its mass is somewhere between that of a smart car and a large motorcycle. It's divided into 3 parts in many different ways. The wing comes apart into 3 parts, 3 fuselages, 3 tails. The power system is divided into 3 power domains for redundancy, and we have triplex avionics for fault tolerance. It's very energy optimized. I think Andy alluded to that. In order to fly in the stratosphere, we are pushing the limits of technology right now and require the airplane to be very highly optimized to be able to stay aloft over long periods of time. The performance is listed there on the slide. We have designed for a 35-degree latitude on the winter solstice, the hardest time of the year to stay aloft. And we project that we can get up to about 60 degrees in between the equinoxes and in the height of summer all the way to the poles. Our ConOps is fairly simple. We envision basically 3 types of missions in terms of how we would operate, either maintaining station over some part of the globe, scanning some search area, or traveling from point A to point B. So those are kind of the broad categories we envision. We are planning for future operations where we have envisioned numbers of these airplanes, but our focus right now is on our initial flight test operations. We're standing up a flight test site in Puerto Rico. And we calculate that we can get the airplane over any part of the world in about 12 days from there, if we choose to. We have 3 comm links on the airplane for C2. We have 2 line of sight radios for redundancy, and those are our primary means of control, and a beyond line of sight satellite link for contingency operations and also future operations beyond line of sight. Our concept of operations is very similar to Zephyr. During the initial ascent, we plan to use a chase aircraft to provide separation from sea level to flight level 180. Positive control from 180 up to 60,000 feet, and then use some combination of collaboration and ADS-B for separation above the stratosphere, above 60,000 feet in the near term. We're also participating in these workshops that have been organized to allow us to interoperate with the other platforms in the future. There are a few things that I think are different about these types of airplanes versus typical airplanes that I think this group has probably thought a lot about, but I wanted to perhaps mention to the larger group here. Fixed-wing airplanes that fly in the stratosphere are big, they're light, they're slow, they fly for long periods of time. Some of that's similar. For example, there's lots of slow quadcopters and things that fly at low altitude, but they have a lot more maneuverability than we do. So we're much larger, obviously, so it's harder for us to get out of the way. Being energy optimized means that if we maneuver, particularly vertically for avoidance, then that may affect our ability to close the energy cycle if we're at a corner condition like middle of the winter at the highest latitude. So we have to be careful about that. We're very susceptible to weather during ascent and descent, so making sure that we avoid any type of severe weather is very important, and very sensitive to wind. The true airspeed of our aircraft is at a nominal altitude is something on the order of 50 knots, so it's quite slow. And as we make our ascent through the jet stream, we anticipate flying backwards essentially. So wind speed is a very important part of our trajectory, and so any type of control of the airplane needs to take that into account. For example, if we're instructed to turn to some bearing, and the wind happens to be from that direction, there may be some chance that we'll actually, even though we turn that direction, we'll be flying the opposite direction. So some knowledge of the wind environment is required essentially to be able to predict our trajectory over the ground. The wind also affects our flight plans. So the flight plans that we have for the airplane will change as the wind environment changes. And it was mentioned contingency, lost link types of procedures. We anticipate that as the wind field changes, we may have to update our lost link procedures on a fairly regular basis to allow us to ensure that we can get back to our contingency runway. So those are some of the considerations that we think are important. The major message there is probably if we're going to be taking direction from a UTM, some allowance for the wind will need to be accommodated into that traffic management system. So I know I'm standing between you and lunch, so I think I'll leave my comments there. Thank you for your attention and the opportunity to present.
Thank you, Gil. And to the both of you, welcome to the family. So I'm not going to take any questions, but I do want to do a quick wind-up on, so what do you need from ICAO? The interesting part about this is they're mostly either American or European companies, but they're not planning to fly predominantly in Europe or the US. They're planning to fly in other places that require the services. These are global services, as you've heard. So what is it that's necessary from ICAO? So we've broken this down into a series of phases. Phase 1, 2, 3, not surprising, but to outline essentially what's happening now, what's happening in phase 2 when you have the stratospheric operations that are coming into play, and in phase 3 when you would expect to have a series of standards and recommended practices in place. So the very first slide that you put up that says Graham, this one, Graham. Okay. So I'll just show you what the timeline, we think the timeline looks like, recognizing that some of these operators are already in place and operating today, as Leo shared with you. So just a short version, phase one is happening for some operators now, but as they come online, as you see, for the next couple of years, those are in cooperation with key regulators from which they originate, of course. And ICAO has already issued a series of state letters to other countries. There are 40 or 50 right now where they're operating routinely. And that will go on, continue to go on. In phase two, you would expect to see some of these aircraft type certified, the ones that require type certification, with the operations also authorized, as you heard earlier, by both local and or possibly regional CAAs or their RSOOs. Sorry for the acronyms. And what you would expect to see is collaboration from the industry with guidance material in cooperation with ICAO provided to those states that are not the US and Europe, but where those operations are ongoing on a routine basis. So we're looking for guidance material in the very short term, the next couple of years from ICAO. Like the rest of the UAS and UAM world, will be evolving over time. With phase three, full-scale operations in selected regions where you have high numbers of these operations hanging around in certain areas, regional areas, for up to a year and beyond on time. So they're really essentially pervasively all of the time. So that's essentially what the notional timeline looks like and what we're asking for, what the sector's asking for from ICAO. With that, that's the end of this morning's session. You've been very kind to be patient. I know you're very hungry. What I do want to introduce is your lunch speaker, in the sense that he has a short briefing for you before. Meituan Autonomous Delivery has sponsored your lunch. We're very grateful for that. Is he here? He is here. Excellent. And so I'd like to introduce Dr. Yinian Mao. Excuse me, let me try that again, Dr. Yinian Mao, who's going to talk to you about Meituan Autonomous Delivery. Thank you again for your patience.
So does this thing work?
It's up. It's coming.
Okay. So I'm the real person standing between you and your lunch. Good afternoon. My name is Yinian Mao, and I lead the autonomous drone delivery project at Meituan. Meituan Dianping is a leading e-commerce platform in China, and we're serving a lot of users every day for meals, for going to restaurants, to go to a movie theater, everything like that. So we started in 2010 as a group buying company, but we soon set our own marks in this industry. For example, in 2011, we were the first to introduce a policy to give a full refund of any expired purchases on our platform, because we think our customers are our number one priority and we should treat them better. And in 2012, we launched what's called Maoyan Movie Ticket. It is an online purchase platform for movie tickets. And today, Maoyan accounts for 60% of all online movie tickets sold in China. And that's roughly $5 billion US going through our platform. And that's one of the small segments in our business. In 2013, we launched Meituan Waimai, which is the food delivery service. And it is the #1 food delivery service in China today. We started very humble. We started with a few dozen meals delivered a day in the first few weeks. And today, on average, we deliver 22 million meals a day. On the 27th of July this year, we reached our peak this far. We delivered 30 million meals on that day. And last night I checked, it is more than the 45th most populous country in the world. So a little bit more than the population of Australia, thus than that of Canada. So there are some other segments of business that I would like to introduce. For example, we started our hotel and travel booking services in 2014, and this is a highly competitive area. In 5 years, we were able to move from 0 to #1 in terms of hotel nights booked in China. So on the 2nd of October, which was a national holiday in China, we booked 3 million hotel nights on that single day. So Meituan merged with Dianping Group in 2015, and we went listed in Hong Kong Stock Exchange last year. So right now we are the number 3 internet company in China in terms of market valuation. So we have quite a few proud number 1 segments in our business, but at our heart, our customers are always number 1. And we have a very simple model, which is we help people eat better and live better. Indeed, our services have changed people's life in a very profound way, especially in China. For example, during the past 12 months, the total number of transacting users on our platform was 420 million, which is slightly more than the half of the urban population in China. And on average, our users do 25.5 transactions in a year. There are 5.9 million merchants on our platform, and our services are present in 2,800 cities in China. So last year, the number of delivery riders, we hired delivery riders, they ride e-scooters to deliver food for our customers. The total number of delivery riders that served on our platform was 2.7 million. Today, China's urban population is at 830 million, and it's still growing. And we believe our business will continue to grow with this trend of urbanization. And as our business grows, we also see some growth problems. For example, we're hiring 720,000 riders on a daily basis these days. And we cannot expect that number to grow indefinitely with our business growth. So that's why in 2016, we started the autonomous delivery project, first with the autonomous ground vehicles, and then in 2017, we started the autonomous drone delivery project. So within Meituan, we have 3 potential customers. Meituan Waimai, which is the food delivery service. Meituan Shangou, which is a new business segment where we help our customers to purchase and deliver items, non-food items, like flowers or medicine, and deliver to their home. And Xiaoxiang, which literally means little elephant. It's a grocery delivery service. We deliver grocery for our customers in local communities. So we believe with the technology innovation, we can gradually build up a whole new fulfillment system in the local communities, especially the last couple of miles. And in this system, our ground vehicles will provide low cost, high efficiency, and our drone delivery system will provide extremely short delivery time and superior user experience. So we plan to start out from local community and then gradually move to a citywide delivery network. And we believe such a whole new fulfillment system will eventually lead to a marketplace upgrade. So we see the value proposition of our drone delivery business in 4 ways. Number 1, it matches our business very well. So we have a slogan, it's called 美团外卖送啥都快. This is in Chinese, and translating into English is we deliver everything in an expedited fashion. So indeed, we have lowered our average delivery time, the meal delivery time, from more than an hour to 28 minutes in the past few years. So second, our platform has a proven scale and reliability in terms of dispatching and route generation. So today, we're generating routes, single routes, in terms of 1/10 of a millisecond. So we're generating on our server farm millions of routes every second, and we pick the best ones to optimize efficiency and user experience. And third, we're doing a lot of R&D in the area of aircraft research, design, delivery, equipment, and infrastructure. So lastly, as the regulatory bodies are experimenting and introducing new guidelines, new rules, we are very excited to be the first to trial and experiment and also provide feedbacks. The result will be a fully compliant, highly safe, and highly efficient aerial delivery system. In short, through innovation and drone delivery technology, we think we can empower more merchants and serve better for our vast number of customers. So we see 3 pillars for our drone delivery business. On the technology side, we believe technology innovation is the driving force. So our research covers, for example, positioning technologies, both with GPS and in GPS-denied scenarios. We also have advanced research in perception and route planning, and so that we can do sense and avoid in midair. We founded a number of research collaboration projects. For example, we founded a project with UC Berkeley team, and they just presented last week at the IROS International Conference on smart robots and systems. And that work is a paper on dynamic obstacle avoidance using advanced control algorithms and onboard decision making. On the regulatory side, this year, CAAC, the China's regulatory body, introduced a number of new guidelines and temporary rules. And we are the first, among the first, to take advantage of that. For example, we have a collaboration with one of the research institutes under CAAC to experiment a system called UTMIS. I'll explain that a little bit later. On the business side, we're also experimenting with new business models, basically enabling our user to use their mobile apps to order online and get their delivery through drones to their home or to their business. So getting a little bit into more details about what kind of technology that we're trying out. On board, we use multimodal sensors, including vision and non-vision based. We equipped our aircraft with advanced sensing capabilities, with advanced computing capabilities. And we combine global route planning on our back end with onboard local route planning to perform obstacle avoidance. We also rely on our existing infrastructure. It's called Meituan Brain. It's a brand name. It's a heavy lifting capability platform to perform real-time and large-scale route generation. So this year we're working with the #2 research institute under CAAC to conduct a pilot program where our aircraft will be able to report its status, including position, velocity, heading, etc., every few seconds to the back end. So this system is called UTMIS. It stands for Unmanned Aircraft Traffic Management Information Service System. For the back end, we also built up our own back end. This is for dispatching, as well as for monitoring the flight status, geofencing, etc. And we're also building more functionalities into this backend. For example, we can change routes on the fly. This is a dynamic route change. And also we can do conflict resolution through our backend. So in terms of aircraft research and design, we're trying to accelerate our pace. You probably heard about China speed, but you probably haven't heard about some term called Shenzhen speed. So that's the China speed on steroids. So we have gone through a few iterations of aircraft design in the past year and performed more than 20,000 safe flights. So looking at long-term to 5 and 10 years, our goal is to establish a citywide delivery system, aerial delivery system, and turn a very small percentage of Meituan's delivery business into UAV-based delivery. So since we're expecting something like 100 million deliveries a day down the road, so that would be a few million deliveries a day by UAV. So to conclude, we see the future of low-altitude, citywide aerial delivery, and we can use autonomous vehicles to deliver everything for everyone, everywhere. And we're working very hard towards that goal. Thank you.
Thank you, very nice. Thank you very much, and turn it back over to you.
Thank you very much, Nancy, and thank you very much, Dr. Mao. Our next session will address the flight rules. It will start at 14:15, so 2:15. We would kindly ask speakers to be positioned on stage at 14:05. Thank you very much.